Okay, this is an introduction video about kinematics. Now, this is actually quite a long video, so I do apologise in advance. A particle P moves in a straight line from a fixed point O. Its velocity v meters per second after t seconds is given by v of t is equal to e to the t sine t, for t being between 0 and 2 pi. Find when the particle P is first at rest for after t greater than 0. Describe what happens to P for this time t. Find the acceleration when t is equal to 3 pi by 2 seconds. Find the maximum speed of P and find the displacement of P from O after 2 pi seconds, and find the total distance travelled for the first 2 pi seconds. The last two questions are quite interesting because we've got to know the difference between displacement and distance. Now, if you differentiate velocity, you get acceleration. If you integrate velocity, you get what's known as displacement. So we're going to find when the particle's at rest. So when the particle's at rest, the velocity is equal to 0. So we're going to put vt equal to 0. So we've got e to the t sine t is equal to 0. So e to the t cannot be equal to 0. Therefore sine t is equal to 0. Now sine is equal to 0 for 0, pi and 2 pi. We wanted the first one after t is greater than 0, so it's going to be this one here. So t is equal to pi seconds. The next thing I'm going to do is draw this using my GDC. So go into my GDC and selecting a graphing mode, and then enter the function. So we got e to the x, you have to put it in terms of x, times sine, so it's trig sine x, enter. Then we need to do a little bit of view window. So we go to menu, window zoom, window settings, and we're going to set them from 0 to 2 pi. Now you don't have to use the pi button, we just put 2 pi, and then we'll just press OK. We're not doing anything for the y. And then the final bit of zoom we'll do is menu, number 4, and zoom fit. And we get a reasonable looking graph. We'll just pull the label out of the way. I'm interested in this point here, which we know to be pi, so we'll just get the calculator to come up with that. So it's menu, analyze the graph, 0 to the left of it, to the right of it, and I've got my value there of pi. Now what happens at this particular point is that here the velocity is positive and here the velocity is negative, and the direct negative says about the direction, so the direction changes from here to here, so the particle will change direction. Okay, and we'll be able to see that a bit later on. So if we we're asked what happens at that time. So at the time t is equal to pi seconds, the velocity changes from positive to negative. Right, now we need to find the acceleration when t is equal to 3 pi by 2 seconds. P changes direction. So for acceleration, when t is equal to 3 pi by 2, we require v dashed of 3 pi by 2. So when we differentiate that, we've got vt is e to t sine t, so we have to use the product rule. Don't confuse this v with this v. The product rule will be v of t is equal to u dv by dt plus v du by dt. So v dash of t is equal to e to the t times cos of t plus sine of t times e of t. So u is e to the t. When you differentiate it, you get itself, and when you differentiate v sine, you get cos. So common factor of e to the t, so we get e to the t of cos t plus sine t. So v dashed of 3 pi by 2 is going to be e to the 3 pi by 2 times cos of 3 pi by 2 plus sine of 3 pi by 2. So now cos of 3 pi by 2 is 0, and sine of 3 by 2 is minus 1. So we get an exact answer of minus e to the 3 pi by 2 meters per second squared. Now we can do this on our calculator. So go to our calculator, go to the home screen again, and select a calculation mode, we select menu, number 4, calculus, numerical derivative at a point. The variable will be t. The value will be 3 pi by 2. We want the first derivative. Press OK, so it sets up the derivative for us. We put our function in, so that's going to be e. Now we have to put it in terms of t because we asked it to differentiate in terms of t, times trig sine of t, enter. Okay, and if we put in our answer we got before, which is minus e, not log e, so just go back. Okay, so e to the 3 pi by 2. We'll see if we get the same answer. We'll see where we got the right answer. So if it was a calculator paper, we would probably write this down. ddt of when t is equal to 3 pi by 2 of our function t times sine t, the full calculator answer, and then it rounded off correct to 3 cylindrical figures. So it's minus 111 meters per second squared, because we're doing acceleration. Right, the maximum speed will happen when v dash of t is equal to 0. So we want to find out where t cos t plus sine t is equal to 0. Well, e of t cannot be equal to 0, and therefore cos t plus sine t is equal to 0. To solve that, we take cos t over to this side. So we get sine t is equal to minus cos t, and then we divide by cos t, we get sine t over cos t is equal to minus 1. Tan t is sine t over cos t, so we replace this with tan t. But tan t is equal to minus 1. Tan to the minus 1 of 1 is pi over 4. Do our South Asian Tennis Club. We want to know where it is negative. So where is tan negative? It's here, the second and the fourth quadrant. So we draw our angles in there, making our angle with the x-axis. We're solving between 0 and 2 pi. So we get t is equal to pi minus pi by 4. Or 2 pi minus pi by 4. That gives me 3 pi by 4 or 7 pi by 4. Now we could do the second derivative, but it could get a little bit complicated. So we just put this into our value of v. So v of 3 pi by 4 is e to the 3 pi by 4 sine 3 pi by 4, which is root 2 over 2 e to the 3 pi by 4. Or v of 7 pi by 4 is equal to e to the 7 pi by 4 sine 7 pi by 4. And we get minus root 2 over 2 e to the 7 pi by 4. Now we're trying to find speed. Alright, this gives me velocity. This one is obviously bigger than that one because you're raising this to 7 pi by 4. So this will be the maximum speed without the minus sign. Speed does not take into account the direction. Now you could do this on your calculator. So go into the calculator and go in here, and then on the calculator you do menu, analyze the graph. We want maximum here. We'll give you this one over here to the left of the right. That gives you the first one. And you can see very clearly that the minimum has a greater magnitude. Okay, so you can actually just do it with the calculator. So the maximum speed is going to be root 2 over 2 e to the 7 pi by 4, which is root 2 over 2 e to the 7 pi by 4 meters, using the GDC, which I just did. Okay, this one we have to take into account this one value here, which is at t is equal to 5.49, but the speed will be 172.6. which is 173 meters per second. Right, part D, for the displacement. Now, if you don't want to get involved with the long involved integral here, please just move along the video towards the end. So if we have to find displacement, we have to integrate the function between 0 and 2 pi of et to the sine t dt. Now, if you want to do the actual integration, you have to use integration by parts, u dv by dt by parts. let u equal e to the t. Du by dt is e to the t. dv by dt is equal to sine t. This is a bit higher level maths now. V will be the integral sine, which is minus cos t. This is the formula for integration by parts. U dv by dt dt is equal to uv minus the integral of v du by dt dt. So e to the t sine t dt will be equal to, just take this from the following page, u times v, so it's minus e to the t cos t, minus the integral of v, which is minus cos t. So a bit of brackets here, be careful, e to the t dt. Just sort this a little bit out here. So we're going to have minus e to the t cos t, minus minus makes a plus, e to the t cos t, and we're just going to call this equation 1. So we've ended up with something that we've sort of had at the beginning. So we've got e to the t cos dt, so we're now going to integrate that. Again, using parts, make sure you make the same one as you made in the first part, and this one dv by dt. Let u equal e to the t, differentiate it, you get e to the t. dv by dt is cos t, you integrate that, you're going to get sine t. Using this formula now, here, we get the integral of e to the t cos t is going to be uv e to the t sine t minus t e to the t sine t. So it would be v du, I've written it du times v just to get the things the same. Now what the problem is here, we've ended up with trying to now got to integrate what we actually started with, which was this. So we'll stop there and we'll substitute this into equation 1 here. So we've got the integral of e to the t sine t will be minus e to the t cos t plus e to the t sine t minus e to the t sine t dt. So what we've done, we've substituted that in here instead of that. So that gives me, now if I take this over here and I have two lots of it, it's equal to minus e to the t cos t plus e to the t sine t plus c, and just write that out again. Dividing by 2, we're going to have e to the t sine t dt, which is what I want to find, is a half e to the t sine t minus cos t, a different constant because we would have divided it by 2. Doesn't really matter. However, we were interested in the integral from 0 to 2 pi of e to the t sine t, so substituting in the limits, we get a half e to the t sine t minus cos t from 0 to 2 pi. So it gives me a half of e to the 2 pi sine to the 2t minus cos to the 2t minus e to the 0 bracket sine to the 0 minus cos 0. You've got to be careful here because obviously cos of 0 is 1. Now sine of 2 pi is 0, but cos of 2 pi is 1. So we're going to have a half of minus e to the 2 pi. E to the 0 is 1, sine to the 0 is 0, cos to the 0 is 1, minus minus is going to give me a plus 1. So we're going to have a minus minus gives me plus 1. Probably better to write it as 1 half 1 minus e to the 2 pi meters. Now, you would probably do this on the GDC. Now, to do this on the GDC, go to the GDC. We've already got the graph. So what we do is menu, 6, analyze the graph, and we go for an integral. We want the lower bound. So the lower bound, we'll just type in 0, and the upper bound write in 2 pi. And all the shaded area gives the displacement. So the value for the displacement, trying to move that across, sorry. Okay, the value for the displacement, for displacement you do not need to take into account whether the area is above the curve or below the curve. This tells you how far it is away from the point 0, and you'll see this in the very last applet that I got for you. So the displacement is going to be minus 262.2. So in an exam you just write down the integral, there's the curve, and then write down the full calculator value, and then it rounded off to 3 significant figures. Now distance is distance you have to take into account whether the area is above and below, and change the negative part to being positive. So one way around that is to get the calculator to integrate from 0 to 2 pi of the absolute value of e to the t sine t dt. So we've got from 0 to pi, this is the same as doing 0 to pi e to the t sine t dt. Instead of adding it, doing minus the integral from pi to 2 pi e to the t sine t dt. So you're going to do it manually, you'll have to do that. However, we're going to use our GDC. So go into our GDC, I'm going to make another graphing window. So another graphing window. Okay, and I'm going to put in the absolute value now. So the absolute value, select this one down here, this catalogue here. You want the absolute value, and write in now the function. So it's e to the x times sine of x. Enter. Change the view windows again. Menu, window zoom, window settings, 0 to 2 pi. Just write pi. Okay, and then again, window zoom, fit. Just move the label out of the way. And to do the integral, menu, analyze the graph, integral, type in 0 for the lower bound, and then 2 pi for the upper bound. And now we've got an answer here, now we can see, of 291. So what this does, it adds this area and this area together. Blue on the original graph, this is below the axis, but what it does, it takes the total distance travelled. Okay, so write down the calculator value and the value to round it off to 3 significant figures, 291. Now, so the difference between displacement and distance is that displacement is distance in a certain direction. So when you're doing this type of problem for displacement, you can just integrate from there to there of the original function, and then on your calculator, if you want to do distance, you take the absolute value, you integrate from 0 to here, but you take the absolute value, which is the red function. So it takes that one, adds it together. And for displacement, it takes that one, it just takes out the difference between these two. And that's what we mean by displacement. And we can just have one last look at this in different format. If we just look at this app, so here we have a number line, and we have the point P at the origin, and that t is equal to 0, the displacement is equal to 0 meters. If we press the start button, and this app is on the notes of the video, press the start button, we'll see it starts to slowly go in this direction. When t gets to about pi, it will start coming back, and then it will go very, very quickly to the value here at minus 267.25. So this gives me the displacement. This distance here is the displacement from the origin. The distance, this going to here and then going back, gives me the total distance travelled. So you can just understand that. So if I just reset that, and if I scroll it through manually, you'll see when we get to about pi, which is about there, it starts to go back again. Okay, so just run that one more time for you. So it moves along slowly, it moves along here. We get to t is equal to pi, and it moves back to a displacement of minus 267.25. Alright, but the total distance travel will be up to there, that bit, and back again, and to there. Okay, so hopefully this has explained the difference between distance travelled and displacement. Thank you very much for watching.